Aloha, Richard Halverson here. This is ICS211, and today I'm going to do the binary search algorithms lab. So let me share my screen. And so here we are. It's this lab, and what we're supposed to do is we're supposed to create an Eclipse project named that, with a class named that implements the solution for the binary search program in section 13.3 of your textbook. Let's see what that one is. That's this one, binary search. And you should have finished this already. And it's probably, I haven't made the video yet for this one, but I will before the calendar date. But anyway, so you should have a working recursive binary search program here, and we're going to take this program and implement it very simply in Eclipse. And then we're going to I want you to demonstrate that you know how to run the program and all that here. And then for step 2, I want you to create another class in the same package called Iterative Binary Search that implements the iterative version of the binary search program that you see in the textbook, and that's this one. Let's see, 17.1. This one. Oh. This is linear. I must mean 17.2. Yes. 17.2. Yes. This here. So this is the iterative binary search. It's, it looks different, but basically you're going to grab this code here. Let's see, is that? Yes, I'm sorry. I did see that. Okay. And then I want you to show that you got that working, and take some screenshots and export the project and submit it below. All right, so let's start with the Eclipse project, and I've opened up my Eclipse workspace. So for all the labs I'm doing, and you see this is the first lab assignment here, and so we're going to start the second one. Let's see, I'm going to create a new, I closed the files that were open, shrunk these up. I'm going to create a new project. And what am I supposed to call that project? Binary search. Create a new, what did I do? Create a new project, new Java project, sorry. And it's going to be called binary search. And that's about it. Finish. That's good. And then I'm going to create inside. I'm going to create a. Let's see if this works. I'm going to go in here, and I'm going to right click, and I'm going to create a new package, and I'm going to call it binary search. And finish. And then inside the binary search package, I'm going to create a new class called recursive binary search. Recursive binary search. And you want it to have a static void name thing. Okay. Finish. All right, so here we are. So we want to go over here, and we want to go over here and grab our finished binary search project over here. And is my code still there? Yes, it is. Oh, this is even still there. That's nice. So I want to copy this. Let's see, I got to make sure this is right. Let me put this here and put this here. And I want to go copy this stuff. Copy. I'm going to pop it right here. Paste. And then I'm going to leave that alone. Oh, then I'm going to take class void main. Where's the static void main is down here. So let me that's here, and that looks the same as that. So I'm just gonna copy from here all the way down to here. There's my static void main, but I want to copy all the stuff up above it. So let me copy this, and I'm going to replace this right here. I'm going to paste it. And then I'm going to, let's see, hold on a second here. All right, so it looks like we have an error there. It looks like we have some errors. We did not declare these variables at the top, did we? Okay, static, the declaration for this recursions variable, the declarations for our comparisons variable are not there. We have to put those in here. Let's put them up here. Static integer recursions equals 0. And these should be in your static int recursions comparisons equals 0. And by the way, to fix, okay, so those errors went away. I'm going to click here, and I'm going to Control A to select everything, and I'm going to do source correct indentation, and there we go. Let me open this up, and so we should see if this works. Let's see, it's going to first ask us. It first asks us for the number of integers, and then it asks us for the integers, and then it asks us for a value to look for to see what the index of that value is, and if that value is not in the sorted array that's input, then it returns a -1. So let's run this. And to run it, let's see what happens when I do this. No, it's not the right one. So let's click on the program, do a right click, and go run as Java application. And that's fine. I'm going to click on save, always save resources before launching, so it doesn't ask me that question anymore. Okay, right now it's sitting here. It's asking me for the number of integers. So I'm going to do 9. And then it's asking me to enter the integers. So I'm going to enter these over here. Why not? Okay. And then I'm going to see if it can tell me the index for number 7. And it says the index is index 6. That's right. 0, 1, 2, 3, 4, 5, 6. And the recursions counter was 1, and the comparisons counter was 3. So it did 3 comparisons, and it called itself twice. All right, but we aren't done, because in here we're supposed to add print statements that will verify the user, that will query the user. Let's see, is this? Yeah, this is right. Yeah, query the user when it is time to enter the input. And so if you look at this thing here, this is the an example execution. You'll see that down here it asks enter the size of, or enter the size for an array, and then enter the array integers separated by spaces, and then enter the target value. So basically, you're supposed to add to your program here these outputs, so the user knows what the heck is being asked. Instead of over here, you notice that it just runs and we don't do, and that of course is an artifact of when we're entering our programs in over here for these Xylabs, we have to enter all the input in at once and so on. So anyway, so let's do that. Let's go over here, and the first thing is okay, let's follow the code. We're gonna open up a scanner. We're gonna initialize an integer array with the number of it's going to read the number, so hold on a second here. All right, so here we're declaring an array list of integers, and we're calling it integers lowercase, and this is a function. A function will return the array list. So this function that was defined up here, and that's this function. And so this function reads in the scanner, or no, it reads in the handler or the identifier for the scanner that was instantiated up here above. And the first thing it does is it reads the size of the array list. So here we want to put out we want to say system out print, and let's just do a print enter number of array elements. Okay, and then that'll read it in, and then we want to say when we're ready to read in the array list, which is right here, it's going to read the number that was entered in here, you see. So let's say system, I'm going to just copy paste over again, copy paste, and I'm going to say enter array elements separated with spaces, whatever. Okay, so that will then you enter the array elements, and then it's going to, that's it. So here, this loop will read the array elements, call the scanner, and then it returns nums. Yes, this is the array list. It's called nums. And this thing adds each element that's read into nums, and then it returns nums. Okay. That's how that works. And then so that takes care of those two. And then the last thing is we're going to be reading in here we input the target value for the search. So we want to say, is my do I still have it in there? Yes, I do. Enter what do I say over here? That is here. Enter, might as well get, enter a target value to search for. That's what I say. All right. Enter a target value to search for. Shouldn't end the sentence in for, but whatever. And then it'll read that in. Okay, so now let's run this. And now what happens when It'll run recursive binary search. Very good. And it says, oh, enter number of array elements. Now what we're supposed to do is we're supposed to try out getting the array elements from here. Like for example, here to get out 125 random sorted array. This will click here, boom, and we have a 125 element array sorted already. So we can just copy this, and we can answer this question 125, and then we're going to paste in what we just copied, paste. There they are, enter, and then it says enter a target value to search for, and we're supposed to search for the integer at index 10. Okay, so and then we're supposed to take a second screenshot of searching for the searching for an integer that's not in the array. Okay, so let's first of all find the 10th integer, index 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 779. So I'm going to put here 779, enter. Index 10. That's how many recursions it took, and that's how many comparisons it took. All right. Well, I'm going to grab this. I'm going to just do a screenshot right now. And this is recursive binary search. Search index 10, that's what I'm going to call it. So I'm taking a screenshot, right? Let me just make this a little bit bigger. And I'm going to do my clipper thing here. And I'm going to click new. And I'm going to grab this. And there it is. There it is. No. So here it is. And I'm going to save it. And I'm going to save it on the desktop. And I'm going to call it recursive binary search index 10. And it's going to save it on the desktop. It should save it on this desktop. There it is right there. Okay. So I got that one. Now, this is done. Now I need to run it searching for something that's not in there. Okay, so I'm gonna it doesn't matter if I use the same array or not. I think I can use the same array. It's in my clipboard, so I'm gonna run this again. Run, and I'm gonna say 125, enter, and then I'm gonna do Control V. Oh, nope, nothing's in there. So I got to get another 125 here. I could just copy this, but I'm gonna refresh it. Here's some new ones, and I'm gonna do copy, and paste. Okay, there it is. And I'm gonna search for 500. 500 is not in there, so I'm gonna search for 500. And I get index -1, recursion 7, comparison sequence searching. Okay. I guess that's right. So let me screenshot this. And this is save as recursive binary search not found. How's that? Okay. So that's binary search, and I've done those two parts. What's next? Next, I have to do this part. Iterative binary search. Add a class to the same package named Iterative binary search that implements an iterative version of the binary search program with input and output similar to step 1. It's easiest to start with a copy of recursive binary search, then replacing the code within this method while referring to this figure in the textbook. Change from counting recursions to counting iterations. Okay. Make sure you also count comparisons. Okay, let's see. So I need to, okay, I'll do what it says. First of all, let me create another class in here, a new class, called iterative binary search. Iterative binary search. And I want to have the void public static void, whatever. And so here we go. Here's iterative binary search. And it suggests I just make a copy. Why do I have an arrow? Because I didn't close my, oh, I never used that. Okay, whatever. So I'm just going to copy all this, I think. Let me save package. Okay. So it's this one. It's either this one or this one. So I'm gonna copy this. Copy, and I guess I don't need that third one, so I'm not gonna copy it. And I'm gonna put that over here. And then I'm gonna go over here and I'm gonna take all of this all the way down to here. Copy. Wait a minute. Is this what I'm really gonna do? Yeah, that's what I'm gonna do. I'm gonna copy from here all the way down to here. Copy. And then go over to iterative binary search, and I'm going to paste it right. Well, I'll just paste it right there. Paste. All right. Now this should run the same, except for it's not really iterative. It's recursive. Okay, and it's not supposed to. So, but let's just make sure that we copied everything over right. So I'm going to run this one, iterative, and I'm going to I'm going to go over here. Let's see, I'm going to change something here. I'm going to say iterative. Iterative. There. And over here, I'm going to put recursive. Just so I can keep them straight. Okay, whatever. All right, let's run this. I'm going to go click on here, run as Java application. And it asks me, it says iterative, asks me number of array elements. So I'm going to do 125, enter, and then I'm going to find 125. I'm going to do a refresh, get new ones. All right, copy, paste. And let's see, 102 is an index 3. 102 is index 3. Oh, index 2, right? 0, 1, 2, right? Okay. So that works. And now what I got to do is I got to change this thing here to iterative. And it says that over here in section, the previous section here, this binary search algorithm. So it looks like this, where we have this, here's the static void main, here's the code, static int binary search that. All right, I'm going to take this, copy. Might as well just take that, whatever. There's nothing else, nothing better, is there? Okay. And I'm going to take that and I'm going to go over here. And it should be like in here. I'm going to do this. I'm going to what exactly did I copy again? Did I copy the name? No. Did I copy the name of the? I did copy the name. Okay. All right. So I'm going to just go ahead and paste this whole thing in here. I'm going to paste it in right here. Paste. And so now I've got this one. And let me select all, Control A, source, correct indentation. Okay, so I want this one to work when it's called this way. So static public, that's okay. Int, that's okay. Int, it's got it. Target integer, that would be, oh, it's the target integer second. Okay, so it's called target, and this is an array list of integers. So I'm gonna copy this. I'm gonna fix this code here so it matches this thing coming in. And then I'm gonna just replace this code down here with this code up here. So we've got an integer called mid. I guess that's okay. These are indexes. This is a middle index. This is the low, this is the high. Oh, these are just integers. Low starts out at 0. Numbers, this is this, it's gonna be array. Oh, it's called integers. It's called numbers. So this is gonna be called integers. Copy this, and so this is called integers, which makes this integers and this integers and this integers. And we can do that. We can do that. We might have to change this. Lower is integers. These are just integers. Okay, that's fine. All right. I think that. Oh no, I think we got to use get, don't we? Get. This has got to be get mid. It's because this is now an array list of integers. Array list of integers. And now that can be get. Oh, this has got to be integers. What is the, isn't this, What's the size of an array list? Java array list size is it's just dot size. Okay, right, dot size. Okay, that's what I thought. So I'm going to try that. Yes, that works. And this is going to be, this is going to be this just like this again. Okay, so I'm going to do this. I'm going to do this here, copy this, and put it here. I've got to do that comparison system. Let me just put this here. Okay. It's not key, it's target. Target. Okay. The errors are gone. Let me first. Okay, so comparisons and recursions do not get added up, but let me see first if this works. This doesn't do anything. This doesn't do anything. Let me just run this and see what happens. Iterative binary search. Number of array elements, 125. Pop in some array. Here we go. I'm just going to do copy again. Copy. Paste. And what kind of target? I'm going to look for 102 again. 102. And index 2 is correct. This didn't register anything because we don't have that anything like that in here. And so what are we supposed to do with that now? We're supposed to make sure we count up we're counting iterations and we're counting comparisons. So each one of these is an iteration, I guess. So iterations plus equals 1. And whatever. Iterations. All right, and so we're counting iterations, and instead of displaying out, we're going to display out iterations. And then we got to add up comparisons, and I would say that this is the comparison. Yeah, I guess this is a comparison. And I don't know. Well, this is definitely a comparison. And I guess I would say that this is a comparison also. but I'm not going to count this as a comparison. Because that's just, I don't think that needs to be counted as a comparison. Let's see what happens now when I run it. Let's run it. And let me put 125. And let me, might as well grab same one, copy, paste. And let's search for 102 again. And it says iterations 5, comparisons 9. I don't know. What does this say? Iterative found is about 5 and 10. Let's see. What is there any clue here? Oh, look at this. I can't see it, but it looks like I might. Let's see. It looks like I might have count that comparison here also, but let's see what these numbers. Let's do what this. Let's do a 125 and find the 10th index. Let's see what we come up with. So this is 125. Let's just run this again. And let me grab a new set of random numbers here. And I'm going to copy this, copy, and here I'm going to put 125, enter, paste, enter. And what's the 10th one? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 755. 755. And we get 5 iterations, 8 comparisons. What is this one? 5 iterations, 10 comparisons. Oh, well, anyway, it's close enough. What would happen if I were to add? I think it would add 5 iterations onto this, and it would end up being 13. Anyway, this, however you count comparisons is fine, just as long as it looks like you're counting comparisons. I guess you can count this as a comparison also. So anyway, the solution doesn't have to be exact. So let me save this one. Let me do a screenshot of this. And we are grabbing, this is iterative binary search. Let me save it. And I'm going to call it iterative binary search index 10. Iterative binary search index 10. How's that? And then I'm going to do, I'm going to run it again. And I have to do index not found. So let me go back here. Grab another different set. There we go. Copy. And I'm going to do 125 again. Enter. Paste. Enter. And let's see. 500 is not in here. I don't see a 500. So I'm going to search for 500. And it says 7 and 11. How does that compare with this one? 7 and 14. Yeah. All right. I wonder, I bet I didn't count. I might have only counted this once. I might have only counted this once because really when you do a binary search, you can use a comparison where you determine if it's less than, equal, or greater than by using the compare, and that would just be one comparison, and then you could count this comparison, and I think that's how I think that is how this one works. But anyway, it doesn't matter. Whichever one you use, that's fine. Just want you to get the idea here. And so let me take a screenshot of this. New. This is iterative binary search. Save. And this is iterative binary search not found, ENG. All right, so I got the 4. Got the 4 up here that I'm going to submit. And the last thing I want to submit is, let me make sure everything is saved, is I want to submit this project, right? That's what it says here. Screenshot, 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 and an export of my project. Okay, so I'm going to export this project. So to do that, I'm going to select File, Export, and then I want to make sure I'm selecting the archive file. I'm going to close this, open it back up. Make sure you're selecting the archive file. Next. I want to do binary search, this binary search, and I want to name it. I'm going to put it on my desktop, and I'm going to call it binary search export. Binary search export on my desktop. Save it in zip format. Finish. And there it is right there. These are my 5 files that I'm going to submit. Okay, so here I am. This is my lab assignment number 2, and I'm all done. Did I guess I didn't really do this. You should do this and see that the recursions just increase by 1 each time you double it. It increases by 1. And so, but here you only have to export the project. So I'm going to start. I'm going to do first. I'm going to do what doesn't matter. Browse. I'm going to select recursive index 10. And then I'm going to select recursive binary search not found. And then I'm going to browse and select iterative binary search index 10. And browse iterative binary search not found. And finally, I want to find my binary search export. All right, so those are my 5 files, and I can click proceed and submit. And I think that's all I have to do. This is when it's graded, that'll be done. Go back to the list, and we see now that I've submitted that. All right, so that is lab number 2. Hope this helps. Thanks for watching.